Oh hey, I didn't see you there. Oh this? I'm just playing Pokemon Unite. This really tiny device. Aren't phones amazing? Hey, wait! Hey! Finally got my phone back. Anyways, technology like my phone here is incredible. On this measly device, you can have millions of websites on your doorstep. You can explore vast worlds in League of Legends, World of Warcraft, or even Minecraft. Or you could show off your favorite dance moves on TikTok. Even the video that you're watching now is on a tiny screen or laptop. But how exactly are you able to see all these things? How are LCD screens able to deliver the visual images that you see? One way to explain this is with quantum electrodynamics. One way to visualize this concept is with the interaction between two electrons. In classical physics, which you are mostly aware of, you have these two electrons moving towards each other and they repel because of their field forces, such as the force of gravity or that nasty sandwich you wanted to get but couldn't because it was too nasty.
However, in quantum electrodynamics, we are now no longer dealing with fields as forces, but instead as the interaction between particles. Here, we're dealing with the quantum realm, a world with teeny tiny particles interact with one another. In quantum electrodynamics, electrons emit things called virtual photons, particles with no mass or charge. The repulsion between these electrons can be caused by their emission or absorption. Now, let's try to visualize the interaction between these electrons using virtual photons, if they're even real.
Hey, what happened here?
Let's say I'm an electron and I suddenly manifest this virtual photon in this ball here. If I suddenly manifest this, I can emit this ball and flip it, causing a reaction and making him move backwards.
Now, the way we can visualize these interactions is through the use of Feynman diagrams, like this one over here. The straight lines here represent electrons, which have mass and charge, while the wavy lines represent the virtual photons, which don't have mass and charge. Basically, these wavy lines represent a photon being emitted or absorbed. There are many other ways to visualize an interaction like this, and this is only the most simplified version. You can have Feynman diagrams like this, 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 this. They're very complicated. But how was this important to us? Well, in quantum electrodynamics, we are looking at things in the subatomic scale. And since the electrons and protons constitute bigger objects, the same principles apply. For example, we can express friction as the force from the exchange of photons on the electrons, creating that opposite force. One thing to note is that since we're dealing with subatomic particles, which is a subset of quantum theory, and photons, or light, which is a subset of special relativity, we can consider quantum electrodynamics as the marriage of quantum theory and special relativity.
To conclude, quantum electrodynamics is an explanation on how field forces may be better expressed as the exchange or emission and absorption of virtual photons on a subatomic scale.
Thank you for watching.